I am Raghavan, chemistry faculty from all fours educational institutions. I welcome you all for all fours chemistry e-learning classes. Okay, that is session 22. Yes, in this session, let us revise once again Heisenberg's uncertainty principle, and we will work some numericals on that concept. Heisenberg's uncertainty principle. In the last session, so we have derived, that is Heisenberg uncertainty principle. Okay, that is Heisenberg's uncertainty principle. Uncertainty principle. Heisenberg's uncertainty principle. Yes. According to the statement of Heisenberg's uncertainty principle, it states that it is impossible to determine simultaneously and accurately the change in position and change in velocity of the electron revolving around the nucleus in three-dimensional space. That is, mathematically, the Heisenberg uncertainty principle is given by the expression like this: delta x into delta p greater than or equal to h by 4 pi, or delta x into m delta v. That means delta p is equals to, p stands for momentum, so that is the product of mass and velocity, so m into delta v, okay, that is greater than or equal to h by 4 pi. Okay, and we also described in the last class, that is delta x is equals to h by 4 pi m delta v. Okay, when delta v is determined to be as 0, then delta x is becomes infinity. Okay, delta x is becomes infinity. Similarly, as we know that, let us calculate delta v is equals to h by 4 pi m delta x. Okay, when the uncertainty in the position, that is delta x means what? Uncertainty in the position of electron. Okay, when uncertainty in the position of the electron is determined to be as 0, this delta x is determined to be as 0, then uncertainty in velocity is becomes infinite. Okay, that is why according to Heisenberg's uncertainty principle, it is concluded that it is impossible to determine simultaneously and exactly the change in position and change in velocity of the electron revolving around the nucleus. Simultaneously it is not possible, but separately we can determine the change in position and change in velocity. Separately it is possible, but simultaneously means at a time it is impossible according to Heisenberg uncertainty principle. And Heisenberg uncertainty principle is contradictory to the Bohr's atomic model. We know that we explained in the last class. Okay, right. So from this, what we can calculate? Uncertainty in the position we can calculate. We can calculate uncertainty in velocity. That means delta p also we can calculate. Uncertainty in the momentum. Okay, we can calculate mass of the particle also. Okay, that is uncertainty principle. Okay, now see, according to Bohr's theory, we understood, like around the nucleus, the electrons are revolving in stationary orbits. Okay, that means we can identify the position as well as the velocity of the electron revolving in circular orbits. Whereas according to uncertainty principle, so we are in the puzzle. He says that it is impossible to determine simultaneously and exactly the change in position and change in velocity. Okay, change in position, change in velocity cannot be determined simultaneously. Okay, that is the concept of uncertainty principle. He says that uncertainty principle, but what we can determine what we can determine now? So according to uncertainty principle, now we are coming to the conclusion that around the nucleus we can find the maximum probability of finding electron around the nucleus, that is in three-dimensional space. Okay, maximum probability of finding electron around the nucleus. Okay, that is the point from this uncertainty principle. So we are coming to the conclusion that instead of change in position and change in velocity, we can identify the maximum probability of finding electron around the nucleus. What is the meaning of maximum probability of finding electron? That is, maximum probability means the 95% probability of finding electron. Okay, that idea is nothing but the orbital. Okay, that we can see further, right? So now this is Heisenberg uncertainty principle, right? Now let us work 1-2 numericals on this. Okay, Heisenberg's uncertainty principle on this. Yes. According to this Heisenberg's uncertainty principle, okay, let us see the first numerical on this Heisenberg's uncertainty principle. Okay. Yes, a microscope using suitable photons is employed to locate an electron in an atom with a distance of 0.1 angstroms. 0.1 angstroms. Okay, what is the uncertainty involved in the measurement of its velocity? That means delta V we have to find out. Uncertainty in velocity we have to find out. So what is the uncertainty in the position is given? He says that 0.1 angstroms. Okay, I repeat the question again. A microscope using suitable photon is employed to locate an electron in an atom with a distance of 0.1 angstroms. What is uncertainty in its velocity? That's what he is asking. Okay, now that is, say delta V is equals to h by 4 pi m delta x. Okay, 4 pi m delta x. Now let us complete the data in this. Uncertainty in the velocity, now we are determining, we are calculating. H is equals to Planck's constant. Okay, h is equals to Planck's constant, that is 6.625 into 10 to the power minus 34 joule seconds. Okay, and pi value is equals to 3.14, and m, mass of the electron, it is considered in SI units, so mass of the electron must be in kg, that is 9.1 into 10 to the power minus 31 kg. Okay, and delta x, uncertainty in the position, that is equals to 0.1 at mass, that is angstroms, that is equals to, as we know that, so it is considered in SI unit and it is also in SI unit, so therefore delta x, that is 0.1 angstrom unit, that means 0.1 into 10 to the power minus 10 meters. Okay, now substitute in this. Delta V is equals to 6.625 into 10 to the power minus 34 by 4 into 3.14 into m, mass of the electron, 9.1 into 10 to the power minus 31 into delta x, that is 0.1 into 10 to the power minus 10. Okay, then uncertainty in the velocity is equals to, okay, that is meters per second will get, meters per second. That answer, final answer will be, so that is 0.579 into 10 to the power 7 meters per second. Okay, meters per second, or okay, meters per second, or if it is R, 5.79 into 10 to the power 6 meters per second. So first, okay, the question once again, what is that question? Around the nucleus the electron is found, okay. So that electron, according to the question, so a microscope is suitable, a microscope using suitable photon, that means photon light, is focusing on the particular electron, okay, at a distance of 0.1 angstroms. They said at a distance of 0.1 angstroms. That means the change in position, he is explaining that 0.1. Okay, this is delta x, he said. So then mass of the electron we understood, and pi value and h Planck's constant value. Substituting all the values, the uncertainty in the velocity of the electron, because now let us understand one more point here. Sir, why we have to do this experiment? See, around the nucleus atoms are invisible, and in that atom, the nucleus, we are imagining that center of the atom, the nucleus is present. Around the nucleus we are imagine that electron is revolving around the nucleus. So to identify that electron, we have to use that is the high frequency photon energy light only. We have to focus on the electron to identify. That means the wavelength of the light to be used to identify a particular object must be greater than its diameter. We know that. So that is why to identify the location of a particular electron, we have to focus high frequency, high energy photon light. So that electron, by absorbing photon energy light, so the electron can change its position instantaneously. It can change depending upon the photon absorbed, it changes its position. So that is why the change in position and change in velocity simultaneously cannot be determined according to Heisenberg's. Yes, that is the concept of the problem. Delta V, uncertainty in the velocity, is equals to Planck's constant by 4 pi m delta x. Sometimes instead of given uncertainty in the velocity, they will give velocity of the particle, okay, and it is certain to this percentage they will give. So that is from given velocity we can calculate delta V, then we can substitute. Okay, let us see if any numerical find like that. Yeah, here it is there. Okay, so concept of this problem is it clear to you? So contents, formula, required formula, then we substituted, and on calculation will get the final answer like this. Okay, right. The problems on this concept is interesting and very important for all the objective examination. Even it is important for our EAMCET examination and IP examination also. It is important for 4 marks. Okay, so therefore please concentrate on the data. So how to read the problem and how to analyze the data. The data collection is very important. Okay, then substitute in the formula, then the calculations you can do, that is not a problem for you. Okay, that calculation part you can do. So that is analyzing the data is very important. That is the important point, right? Now coming to the next problem based on Heisenberg's uncertainty principle. Okay, let me read the problem once. A golf ball has a mass 40 grams, okay, and a speed of 45 minutes per second. If the speed can be measured within accuracy 2%, if the speed can be measured within accuracy of 2%, calculate uncertainty in the position. Okay, uncertainty, that means now we have to calculate delta x. Delta x we have to calculate. So uncertainty in the position, so it is delta V. Yes. Now let us see the concept once again. What is the problem? So it is a golf ball. What is the mass of the ball? He said that mass of the ball is 40 grams. Okay, the mass of the golf ball is 40 grams. The mass of the golf ball is 40 grams. Okay, be careful. Pi value we know that it is 3.14 and Planck's constant we have to consider. Let us see. Next, what is V is given? V is equals to velocity. How much it is? So it is 2%. That is how much? It is velocity. It is moving with a speed of 45 meters per second. Okay, it is given meters per second, right? It is given 45 meters per second. How much accuracy? If the speed can be measured within accuracy of 2%, that is per 100 accuracy is 2%, then per 45 how much? Okay, per 100 accuracy is 2, per 45 how much? Okay, now that is per 45 it is how much? That is equals to, that means delta V is equals to 45 into 2 by 100. Okay, that is the delta V. Okay, accuracy, that is 2% accuracy is there. So that is the golf ball is moving with a speed of 45 meters per second, and what is the accuracy in that? 2% accuracy, that is 2%. Then per 45 how much? So that is delta V, we can calculate like this. Okay, now that is delta V. Substitute in this. Now wait, see delta x you are calculating, that is uncertainty in the position. Now we should be very careful while taking the data of Planck's constant. Okay, it is given in grams, that must be very careful. It should convert into kg. It should be converted into kg. That is how we can convert this into kg. That is equals to 40 into 10 to the power minus 3 kg, because 1000 grams, okay, is equals to 1 kg, right? Based on this we can calculate. It is only 40 grams. Okay, now substitute the data. Right. Delta x is equals to, yes, we should be very careful. It is kgs, means SI unit, and then it is given in meters per second, that is also SI unit. Done. Next one. Yes, Planck's constant value 6.625 into 10 to the power minus 34. It is joule seconds. Okay, got it. Now once again let us verify the data. H is the Planck's constant we selected in joule seconds, that is SI units. So it is pi value 3.14. Mass of the golf ball is given 40 grams. Okay, we converted into kgs, that is SI unit. Next, delta V. Velocity of the golf ball is given. From this what he said, the accuracy is 2%, they said. So per 100 it is, accuracy is 2. So then per 45 minutes per second, that is meters per second, what is the accuracy? So then we calculated that delta V is equals to this much. Okay, now substitute the content in the equation. So that is 6.625 into 10 to the power minus 34 joule seconds by 4 into 3.14 into mass of the golf ball 40 into 10 to the power minus 3. Okay, 40 into 10 to the power minus 3, it is kg. Okay, done. Into delta V substitute, let us substitute that is 45 into 2. Okay, so it is 100. All right. Okay, so then delta x we can calculate it as, yes, how much? That is 1.46 into 10 to the power minus 33, that is meters. So this is the concept of the problem. Okay, once again, just let us go through the problem once again. A golf ball of mass 40 grams. A golf ball of mass 40 grams is moving with a speed of 45 minutes per second. 45 meters per second. A golf ball of mass 40 grams is moving with a speed of 45 meters per second. Okay, so calculate the uncertainty in the position of the golf ball. That is the problem according to that. Okay, now the data we are collecting. The golf ball 40 grams is converted into kg. Okay, and because it is already given in meters per second, SI unit, so therefore the mass we are converting into SI unit, that is in kg, right? It is converted. Then Planck's constant value in SI unit, that is 6.625 into 10 to the power minus 34 joule seconds. Okay, then pi value we have taken, and mass of the golf ball we converted into kg. Yes, and velocity is given 45 meters per second. 45 meters per second. Okay, so this much of speed it is traveling. Yes, what is this accuracy in that? In that accuracy is only 2%, they said. So per 100 the accuracy is 2. Per 45 you have to calculate accuracy is how much. Per 45 it is calculated, that is like this, 45 into 2 by 100. Okay, this is delta V. Now this is delta V, that is meters per second only. Okay, this is meters per second. Okay, now substitute the data in the formula. Planck's constant value, pi value, and mass of the golf ball, and it is delta V is equals to 45 into 2 by 100. Okay, so on calculation 1.46 into 10 to the power minus 33 meters. Okay, that is uncertainty in the position of the golf ball we calculated like this. Okay, once again the problem is, I read the problem again. Okay, a golf ball has a mass of 40 grams and a speed of 45 meters per second. If the speed can be measured within accuracy 2%, calculate the uncertainty in the position. Okay, so the uncertainty in the position we calculated. Okay, is it clear? It is the Planck's constant value, and this is the pi value, and mass of the golf ball is given 40 grams, and that is in kgs we have this much, and that is based on this velocity of the golf ball we are determining delta V, uncertainty in the delta V. Okay, so uncertainty in the velocity of the golf ball we calculated this much. Okay, then substituting all the content in this equation formula. Okay, so on simplification, uncertainty in the position is calculated like this. Okay, this is the problem. Okay, one more numerical, let us work on that. Yes, next problem is, concept is same but the different numerics. An electron has a speed of 40 meters per second. How much speed it is traveling? 40 meters per second. Okay, accurate up to 99.99%. Accurate up to 99.99%. Okay, what is uncertainty in its location? What is the uncertainty in its position? That we have to calculate. Okay, yes, uncertainty in its position. The formula remains the same as it is. Okay, now based on the given data, yes, let us write. Yes, I repeat the problem now once again. An electron has a speed 40 meters per second. Okay, the electron is moving with a speed of 40 meters per second. Accurate up to, accuracy is how much? That is 99.9% is accuracy. So what is uncertainty in the position of electron? So write uncertainty in the position of the electron. Okay, and we know that the Planck's constant value, we know that. Let us consider all in SI units only. Okay, that is 6.625 into 10 to the power minus 34 joule seconds. Fine, very good. Next, pi value, we know that how much it is? 3.14. Yes, consider. Then mass of the electron is, that is a standard, that is 9.1 into 10 to the power minus 31 kg. Yes, that also we know. Now delta V we have to find, that is the delta V we have to calculate. But how much speed the electron is moving? Electron is moving with a speed of 40 meters per second. Okay, and how much accuracy? So it is, accuracy is 99.99% accuracy. Okay, that means delta V is equals to 0.01 by 100, that is 99.99% accuracy. Okay, into 40. He said velocity of the electron V is equals to 40 meters per second. 40 meters per second. So that is into 40. That is equals to delta V, we can say 0.004. 0.004 meters per second. That is uncertainty in velocity. Delta V is this much. Yes, 0.01. Yes, it is moving with a speed. The accuracy is 99.99% accuracy. So 100 minus 99.99, that is equals to 0.01. Okay, so 0.01 by 100 into 40, that is delta V. We can calculate this much. Now substitute in the formula. Delta X is equals to Planck's constant by 3 into pi value is substituted, and mass of the electron is 9.1 into 10 to the power minus 31 kg into change in velocity 0.004. So it comes total, that is delta X is equals to 1.45 into 10 to the power minus 2. 1.45 into 10 to the power minus 2, that is meters. Okay, this much we can calculate. Once again, the problem is the numerical. Once again I read it. An electron has a speed of 40 meters per second. So the electron is traveling with a speed of 40 meters per second. Okay, this much speed. And what is the uncertainty in its location? Means uncertainty in its position. That means delta X we have to find out. Okay, this we have to find out. Now the data we have to collect. The Planck's constant value we consider in SI unit, and pi value we know that. Mass of the electron we know that is in SI unit. Then the velocity of the electron is given, how much it is? 40 meters per second. Then we have to find it, that is what he said, how much accuracy. So accuracy in the velocity is 99.99% accuracy. So it is 0.01 by 100 into 40. So that gives, so that is uncertainty is this much, very less, very less. So therefore delta V, substituting all the values in this. So finally the uncertainty in the position or uncertainty in the location of the electron can be determined like this. That is 1.45 into 10 to the power minus 2 meters. That is uncertainty in the velocity of the electron. That is uncertainty in the velocity, this much we find. So finally uncertainty in the location of the electron we determine like this. Based on this uncertainty in velocity we can determine like this.